Welcome to Data Do Library. In today's video, we will talk about long division and synthetic division. Let's get started. First, let's talk about long division. We will begin with an example. Let's say we have some function that is a polynomial. The reason for long or synthetic division is to divide a polynomial by another polynomial, something that you may know, or something that you may be given. So very often you'll be given that this polynomial is divisible by a number. So in our case, we're going to say that x equals 2 is one of the roots of this polynomial. What this means is that this polynomial is factored into x minus 2 times some other function we're going to call a g of x. So this f of x can be written as x minus 2, which I got by just subtracting 2 over to the other side, x minus 2 equals 0. And if you recall from finding roots, you set factor equal to 0 and solve for x. So now we're just doing it backwards. So I know that x minus 2 is one of the factors. What I want to find now is what is that g of x. So if I divide both sides by x minus 2, g of x is nothing more than f of x divided by x minus 2. So the first way is going to be long division. I'm going to take 6x cubed minus 19x squared plus 16x minus 4, my polynomial. I'm going to divide it by x minus 2. Long division is not something that's new to you. You've seen it in elementary grades. This is just a amped up version of it. So the first thing you want to do is divide 6x cubed divided by x. What do I get is 6x squared. And that 6x squared will go here. Now I'm going to multiply 6x squared times x. That is obviously 6x cubed. And 6x squared times negative 2, which would give me negative 12x squared. If you recall in long division, now I'm going to subtract that from the top. Just keep in mind you have to distribute the negative. 6x cubed minus 6x cubed obviously goes away, so that's 0. And now this negative will turn into a positive because of this negative in front. So negative 19x squared plus 12x squared is negative 7x squared. Now I'm going to bring down the 16x, so plus 16x, and repeat this process all over again. So negative 7x squared divided by x, that is just negative 7x. And now I'm going to multiply again to get my values down here. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. Now again, I'm going to subtract this. In other words, I'm going to change the signs of everything down here at the bottom. So I have this to turn into a positive. This now becomes a negative. These cancel. 16x minus 14x is 2x. And I'm going to bring down my last piece, which is negative 4. And 2x divided by x is just 2. And 2 times x is 2x. And 2 times negative 2 is negative 4. Again, I'm going to subtract this whole value, which means change the signs. And notice this turns into a 0. In other words, there is no remainder. Finally, I can write this polynomial, f of x, as x minus 2, which was the value given to me, times 6x squared minus 7x plus 2. This polynomial here has a special name. It's called the depressed polynomial. It's not depressed because it's very sad. It's simply depressed because it's 1 degree less than what our original polynomial was. Another thing you could notice is that now this polynomial became a quadratic polynomial. There are many methods I'm sure you're aware of to factor this polynomial to get the remaining roots. In this case, this polynomial does factor, and you would have x minus 2 times 2x minus 1 times 3x minus 2. In which case, this provides us with 3 real roots. We can set each parenthesis equal to 0 and then solve for x, and that would give us 3 real roots. Now I would like to show you synthetic division with the same example. With synthetic division, we're not going to write out the whole entire polynomial. All we care about is the coefficients that are in front of each of the powers. Now it's really important that every power is accounted for. So if you're missing a power, you have to make sure to put in a 0. So in this case, every power is accounted for. Notice we have cubed, squared, first power, and no power. So I'm going to write out all the coefficients of these powers. I have 6, negative 19, 16, negative 4, and all that will be divided by 2. So the first step is to bring the 6 down. I'm going to put that here. And now I'm going to multiply 2 times 6 and put that result here. 2 times 6 is 12. And now add. Negative 19 plus 12 is 7, negative 7. And now I'm going to repeat that. 2 times negative 7, negative 14. Add those two values, I have 2. 2 times 2 is 4. Add those two values and I have a remainder of 0. Now because this is going to give me a depressed polynomial, it means that it's going to be 1 degree less than what I started with. So if I started with x cubed, I now am going to start with x squared minus 7x. Since there's no sign in between 7 and a 2, let's assume that it's a positive, plus 2. Which means I can rewrite this polynomial, f of x, as x minus 2 times 6x squared minus 7x plus 2, which is exactly the same thing what I got from long division. And as you can tell, this way is much quicker and much simpler than the previous example with long division. As always, I encourage you to pause this video and try this example, which you have this polynomial function x to the fourth minus 10x squared minus 2x plus 4, and we're going to divide it by x plus 3. One thing to notice is that x cubed is missing. If you're using the synthetic division method, make sure that power is accounted for. So I'm going to list all the coefficients. The coefficient of x to the fourth power is 1. X cubed is not there, therefore I'm going to put a 0. X squared is negative 10. X is negative 2. And then x to the 0 power is just 4. And I'm going to divide this by negative 3 because when I set this equal to 0, x is equal to negative 3. So as before, I'm going to bring 1 down, the first number down. I'm going to multiply negative 3 times 1. I have negative 3. 0 minus 3 is negative 3. Multiply by negative 3 again. That is 9. Negative 1. Negative 1 times negative 3 is 3. Positive 1. Negative 3 times 1 is negative 3. And gives me a remainder of 1. So again, because this is a depressed polynomial, I'm going to fill it in with powers starting with 1 less than what I started with. So I started with a 4, I'm going to fill it in with x cubed minus 3x squared minus 1x plus 1 plus the remainder of 1 over x plus 3. So my final answer would be x cubed minus 3x squared minus x plus 1 plus 1 over x plus 3. In this last example, you're given a polynomial of degree 4, but you're also given 2 roots for this example. You're told that these 2 are indeed roots of this polynomial. can you find the other two roots? So again, we're going to use synthetic division because it's just that much faster. I'm going to start by putting all the coefficients in, which are 2, 7, -4, -27, and -18. And I'm told that x minus 2 is a root. In other words, if I set that equal to 0 and solve for x, I have 2 here in the box. So I'm going to bring the 2 down, and again, multiply 2 times 2 is 4. I get 11 when I add them. Multiply by 2 again, that's 22. Subtract 4, which is 18. 2 times 18 is 36. -27 plus 36 is 9. 9 times 2 is 18. And the remainder of 0, which is what you should expect because you're told that x minus 2 is a 0, so it's always going to give you the remainder of 0. Now I'm going to fill in this depressed polynomial. Since I started with a fourth power, I'm going to start with one less, which is x cubed, plus 11x squared, plus 18x, plus 9, and obviously the remainder of 0. Now I'm given that x plus 3 is another root, which means I'm going to do this synthetic division again, but now I'm going to do it with this polynomial, not the original. So once again, I'm going to use synthetic division here. I'm going to write out all coefficients first. And since x plus 3 is a root, -3 will go into my box. I'm going to bring the 2 down, times -3. That is -6. 11 minus 6 is 5. Times -3 is -15. 18 minus 15 is 3. 3 times -3 is -9. And again, I have a remainder of 0, which again should make sense because x plus 3 is a root. Now I'm going to fill it in with a depressed polynomial, but it's a depressed polynomial from this depressed polynomial. So we're depressing it twice, which means we have 2x squared, because we started with a cube, now it's going to be one less, plus 5x plus 3. So finally, our original polynomial, f of x, can be written as x minus 2 times x plus 3 times 2x squared plus 5x plus 3. But we're not done yet. We can take that 2x squared plus 5x plus 3, since it's a quadratic, we can try to factor or use quadratic formula or completing the square or whatever other methods you may know. And in this case, again, this is factorable into 2x plus 3 and x plus 1, which means I can replace this quadratic with 2x plus 3 and x plus 1. Now to find roots, all I have to do is set each one of these parentheses equal to 0, and that will give me all of the zeros of the function. As always, thank you very much for joining me. Make sure you like and subscribe, and I hope to see you next time. Take care.